Yes, dear student, now I will be discussing here work done in rotating electric dipole in uniform electric field. Work done in rotating dipole in uniform electric field. In this figure, a dipole having charges plus q minus q, separate distance 2a, is placed in uniform electric field making angle theta 0. In figure dipole V equal to 2aq is placed in uniform electric field, is placed at rest in electric field making angle theta 0 with direction of P. So it is experienced. So the torque acting on it, torque acting on dipole tau is equal to Pe sin theta 0. This is the magnitude of torque acting on dipole when it is placed making angle theta equal to theta 0. This torque will turn the dipole to bring it in a stable equilibrium condition. Means it will try to align the dipole parallel to field. If you want to rotate it from this position this way with constant speed, then you need to apply equal opposite force. So, if dipole is to be turned away from equilibrium position with constant speed, then an equal and opposite dipole torque is to be applied from outside, or in simple word you can say external torque required. But as theta changes, torque changes. But as theta changes, torque changes. Since tau is equal to Pe sin theta है, here P fix is E fix, uniform field है, only theta will increase, the torque will increase. तो variable torque हुआ. How to calculate work done by variable torque? So we use integration method. Now, so work has to be done against, you can write here, work is to be done against variable force, against variable torque. Now here I written constant speed. I have talked here. Okay, if you want to rotate the dipole in constant speed, if you apply torque more than this, which is acting due to electric field, then there will be a net torque which will produce angular acceleration and angular velocity will increase, and hence rotational energy will increase. And we want only to calculate the work done only rotating. So I said with constant speed. So if d theta be the angular displacement, then work done by external torque, then work done by external torque dW, tau into d theta, and what is tau here? Pe sin theta 0, or dW is equal to Pe sin theta 0 इनिशियल है ना, थीटा 0 से d थीटा एंगल घुमाया d theta. So work done in rotating dipole from theta equal to 0 degree to theta equal to theta, we integrate dW within limits 0 to theta, and hence W is equal to integration 0 to theta dW is equal to 0 to theta Pe sin theta 0 d theta. By integration you will learn integration sin theta is minus cos theta. Integration sin theta d theta equal to minus cos theta. तो P कांस्टेंट है तो W इज इक्वल टू Pe माइनस कोस थीटा 0 to theta. Then when we open limits, we use upper limit minus lower limit. So W is equal to Pe minus cos theta or minus cos 0. So it will become how much? Suppose it will be given by W equal to Pe minus cos theta or plus 1 minus 1. So Pe into 1 minus cos theta. This is the work done in rotating dipole from equilibrium position through angle theta. If anyhow the dipole is turned from theta 1 to theta 2, if however dipole is turned from theta 1 to theta 2, then W is equal to Pe cos theta 1 minus cos theta 2. But generally, when dipole is left free in electric field, it will align itself parallel to the field. Now, in last video, restore on dipole, I told you the condition of equilibrium, stable equilibrium. So when dipole is in stable equilibrium, when P parallel to E, and unstable equilibrium when P anti-parallel to E. So generally question is asked how much work will be done in rotating electric dipole from stable equilibrium to most unstable equilibrium. तो how much angle it turn? भाई इक्विलिब्रियम कंडीशन ये है, घुमाया प्लस क्यू, अब आपका माइनस क्यू उधर आ जाएगा, प्लस क्यू उधर, और अब ये एंटी पैरेलल होगा. हाउ मच एंगल है टर्न? 180. cos 180 is -1. Please learn these things. Students, don't remember all these things, values of trigonometric function. Even sin 45 is not remembered by students. Sin 45, cos 45, tan 45. Please get a habit of keeping the thing in mind. Only then you can increase speed. So if dipole is turned from stable to unstable equilibrium, so W बराबर equal to PE 1 minus cos 180. So cos 180 minus minus plus. Sorry, ये पर. So it is 2 PE. 2 PE. Still there are many things left about dipole in coming chapter. When we study chapter of potential, there is one more thing, potential energy of dipole. We will talk later on. So now I want to demonstrate some question to you which create trouble for you. Suppose here a dipole has charges plus minus Q equal to 200 microcoulomb, separated by distance of 10 centimeter. So they ask, write what is the torque? What is the dipole moment? What is dipole moment? This is one question. What is dipole moment? Number two, if this dipole is placed in uniform electric field, of 10 to power 4 Newton per Coulomb, making an angle of 30 degree, then calculate the torque. Calculate the torque. The magnitude of torque, I should say. Magnitude of torque. I think you are clear about the word magnitude. Quantity. So here mistake is done while calculating dipole moment. Actually P equal to 2AQ is the magnitude of dipole moment. 2AQ. I mean, अब separation to 10 centimeter. First, it is given in centimeter. You have to put in meter. Secondly, 10 centimeter. What is this? It is 2a itself. 2a is the distance between two charges, but by mistake student used a. So here P simply how much? So P is equal to here 10 into 10 to the power minus 2 meter. 2a हो गया 2a cube. P is equal to 2a cube. And Q 200 microcoulomb, 10 to the power minus 6. Convert coulomb into microcoulomb to coulomb. So it is 2 10 to the power 3 and it is minus 6, minus 8. 10 to the power minus 8 or into 10 to the power 3. 10 to the power minus 5 Newton, coulomb meter. This C capital M is small. This is the mistake here written by students. They treat it as A while it is 2A. Be careful while calculating this thing. We have noticed this mistake done. Now torque acting on dipole. Tau is equal to P sin theta. P you have calculated 2 into 10 to the power minus 5. E हमने अभी कैलकुलेट 10 to the power 4 sin 30. Sin 30 1 by 2. This 2 cancel. Only left point 10 to the power minus 1. यानी कि 0.1 Newton meter. Which is the torque on dipole. This way you can solve many questions. Sometimes they don't give the charge. They say the torque acting on this is the torque acting on dipole is they say 10 root 3 Newton coulomb, Newton meter. If separation of the dipole to two charges is 10 centimeter and orientation of theta is 60 degree, what is the value of each charge? They say torque acting dipole in field when placed at 6 degree is 10 root 3 Newton meter. If separation between two charges is 10 centimeter, what is Q? So now you are asked here to find Q. So Q equal to P here 2a into Q into sin theta. E sin theta. So suppose E is again here 100 Newton per coulomb. So torque is given 10 root 3. 2a 10 and 10 10 1 minus 2. Q you have to find out. E 100 sin 60. Sin 60 I hope you remember root 3 by 2. So 10 root 3 10 to the power minus 1 into Q into 100 into root 3 by 2. This 0 cancel here, root 3 cancel here, ये 5 जा, तो पावर क्या बची भाई? Q बचा हमारा सिर्फ 2, 5 to 10, 2 coulomb. So this way you should be able to solve the problem easily, but be careful that you have to apply MK system and SI system. Here you have to use in every calculation unit of charge as coulomb, distance as meter. Thank you.